There we go. Is that time again? We're going to talk about Silverlight. How many of you know what Silverlight is? Okay, that's a good call. Then you're in the right room. My name is Sean Wildermuth. I blog, I write, I teach, I do stuff. There's a couple familiar faces in the audience, and at least one that I don't care for a whole lot, but he knows that. Today we're going to talk about Silverlight and security. And I really break this up into a couple of different pieces. First, my job is to scare you, because most of you are doing Silverlight development of some end. How many do you think that Silverlight as a platform is safe to do any sort of development in? Anybody? Everyone's scared to raise their hand now. A couple people. Well, the reality is that Silverlight is, I'm a big fan of the platform, but it is a RIA technology. It's a technology that's delivered over the web and running on your users' desktops. That means it's inherently insecure unless you design your applications correctly. Now, managed code doesn't solve this. So I'm often asked, or even told, that someone's moving to Silverlight because they want more protection than they're getting from JavaScript. Thank you. I'm not that thirsty. And the fact is that Silverlight in some ways is even less secure than JavaScript because we don't have many good JavaScript tools to decompile into the original language and get rid of obfuscation like we do in Silverlight. So there's a couple of different threats here. There's people that are trying to break into web apps in traditional ways, people breaking into servers. We have the idea, if you want your application to be secure, your data centers to be safe, what is the best approach? And this is, don't plug the wire in. That's inherently the most safe data center, and that is one that has no connectivity to the outside world. I don't suggest that, but it's the reality. So let's talk about some of the vectors. We have our typical app. User's going to go through some client, whether that's a phone, whether that's a web browser, whether that's a out-of-the-browser app that's being run. And at some point, you have some data center with some servers behind a firewall, and you have the magic of the internet between them. We know about traditional eavesdroppers using packet sniffers and such to see what's going across the wire and try to steal information. We can solve that in typical web ways with SSL, homegrown encryption, and some other tricks. But that's a pretty well-known problem. Being able to handle these guys, people that work for your company that are going to steal credit card numbers or social security numbers, people hacking into the system, physical security, even stopping people from accidentally walking into your data center and walking out with USB drives. The vector that's different here is on the client. We have users and what I'd call traditional hackers. Now, users is an important one because built into some of the way that Silverlight works is there's a trust with the user. We store stuff on the user's machine. And this is very different from typical web development. Typical web development, you're doing a lot of processing on the web server and then delivering something that will draw the markup on the screen for the user. There may be more interaction with JavaScript and such. But out of the box, most of it, Silverlight is doing a lot more than you typically think about. Because typically, you're writing code in Silverlight to interact with the server in one way or another. Whether that's getting dealing with authentication, writing out to databases, whatever the case may be. And the tools that we're looking at here, things like Reflector and Silverlight Spy, debuggers, even memory profilers. So here's your client, right? You've got your zap file for your one banking application you're going to release. And you've got a bunch of stuff in it. The reality is that this is a zip file, right? This zip file means that I can open it, I can look at it, and I'll show you the most egregious or the most wonderful way to do that. You could do it by hand, but Silverlight Spy automates a lot of that. Is Kuhn here? I thought I saw him walk in. He actually wrote this to his first floor software. Is that right? So the reality is, as we look through the code and assets, pretty much anything we want is here. You can even look at runtime information, what's in isolated storage, etc. What's the user interface. So this is just as easy as HTML wireframes plus JavaScript. There's nothing magical about this. Usually the first thing I do is have someone raise up their hand and go, but I've obfuscated my Zap. That should be good enough. Anyone use obfuscation? That is going to give you a lot of protection. But you can't assume it's going to give you full protection. Why? Because at some point that code, those strings, those magic keys, whatever you're using to protect it, have to be unobfuscated and run. And so with a memory profiler, I can still look at that stuff. I have to be a more seasoned hacker to do that. But hacking didn't start with managed code. We used to run decompilers on old C code. It's harder to look at, it's harder to decipher, but at some level, that stuff becomes machine code in memory. And so you can't assume that anything you're running here on the client is safe. Now, you may say, well, there's a bunch of stuff that I don't care about. It can be unsafe, and that's perfectly fine. The goal really for me is to make sure that you get that. Whoops. Was there a minute ago? Come on. So what are we talking about? We're talking about protecting code, protecting XAML, protecting assets, storing secrets, isolated storage, and then data. So let's kind of walk through some of the scenarios here. Now, obfuscation gives you some protection here, but it is limited protection. It has to be code at some point. So if I was running a stock analysis company, and part of our IP was algorithms that detected or that predicted stock prices over the 5 years or 2 minutes or whatever they do, the algorithm is key to my company. I would never, ever, ever have that algorithm in memory. I would always hide it someplace, behind the server, behind a service layer, never in the Silverlight code. Because it really depends on how valuable the thing you're trying to protect is. Most of the code we write isn't worth protecting. Your event handler to make the button pop up a message box isn't worth protecting, no matter what your bosses tell you. XAML has almost no protection either because it's actually stored as text. Obfuscators can make it hidden, but of course it has to be a DOM at some point in runtime. Don't worry about protecting the XAML, frankly. If you're really worried about people stealing your design, screen prints are going to do more damage to your design than them actually looking at the XAML, honestly. You should take the approach with the XAML that you do with HTML. It's open, it's free, people are going to borrow ideas, and that's actually in some ways why the HTML community works. People go, oh, that looks cool. Let me make sure my site looks exactly like Twitter, which evidently everyone's tried to do. Whoops. Can you hear me now? So assets. Assets also don't get a whole lot of protection, some obfuscation. What are you concerned about assets? Is it pictures? Is it binary files of some sort? The only one that you really have to be a little concerned with is fonts. Because when you use a font, you're agreeing to a license to not give away that font to everybody that uses your app. But luckily, Silverlight allows you to do that with subsetting fonts in Blend pretty easily. If you're not familiar with subsetting or using the font manager in Blend, you should go home right now and Google it with Bing. So let's talk about secrets. I've been teaching Silverlight for a long time now. At least it feels like a long time. And a lot of the students we have are people that have been using WCF for a while. And one of their first complaints is, what do you mean WCF doesn't work out of the box with Silverlight? Well, WCF out of the box comes with WS security as its binding layer. WS security requires secrets. The reason it doesn't work with Silverlight isn't because Microsoft is lazy. Why is Microsoft lazy? Isn't because they're lazy, it's because Silverlight can't be trusted with secrets, right? Maybe private keys would be okay here, maybe obfuscation, some other hiding. If you're writing a banking application, don't do it. If you're writing Bob's memorabilia store, maybe it's okay. If you're writing a Twitter client, go for it. It doesn't matter. It's what level of protection. And with all of this stuff, don't think you can't write good applications with Silverlight. Just know the limitations of security and make the smart, educated decisions. What is the worst thing if someone stole that secret? What was the worst they could do? Get into your web service for a little while? Maybe that's awful, maybe that's recoverable. Make sense? Isolated storage. There's a wonderful class called Isolated Storage Settings. So it allows you to very easily just store stuff, name-value pairs, in isolated storage. But users can get at it. Now, how many of you know where isolated storage is stored? A couple people. Let me show you this because it always entertains me. Hopefully it'll entertain you, but I'm not really concerned about you. So users, and this is on Win 7. It's a little different in different versions, but it's pretty close. Swildermuth. Oh, now you know my username. That wasn't the one I wanted to go to. Local Microsoft Silverlight. IS. So I don't know how well you can see that in the back. Squint a little, it might help. But it's under the user store, app data, local low, Microsoft Silverlight, and the cleverly named IS directory. Isolated storage. And under this directory, they have these obfuscated names for the directories. And the store. So I happened to pick one that didn't have any data in it, luckily. So here's a player ID text that someone put in. Some data that they wanted to store. So you might think, my mom's never going to go there, right? Well, luckily search is built in, right? So let's go back to right? It's going to find this stuff pretty easily, especially with integrated search, even if it's not indexed. So don't store stuff there that is, connection strings, user IDs, passwords. It's incredibly unsafe because the user has full access to it. Isolated storage often is talked about this place of it's kind of a protected data store, but it's protected from you, not from. The data isn't protected from the user, it's only protected from you. So it's important for you to kind of get your head around that. And finally, the one that probably bites people the fastest is data. So in my last talk, I asked the informal survey what people were using for data in Silverlight. Let me see if the numbers are similar. Who's using WCF? Who's using RIA services? Data services. That's about the numbers we got before. So the problem with data is surface area, right? This tends to happen in WCF more than it does the other two technologies. So WCF, I had written a service for someone to use against a rich client or maybe a website. And I want to reuse that WCF client, so I created a new endpoint so it would work with Silverlight. And then I go and get the employee list so I can list the employees to do something like sick time, right? Problem is all I need is employee ID and their name. What's in that employee record? I've written this business object layer or this model for my data. And when I get it, does that mean I'm going to be getting the entire user ID over the wire? I'm going to be getting user, username, maybe social security number, maybe wife's name, maybe address. All that data is a large surface area for people to hack against, whether that's coming across the wire, whether that's the user wanting to do something nefarious. So only, often it's talked about to limit the surface area of your data because you want it to be fast. That's great, but the much greater danger to me is the security of that data. I don't want a hacker to know my social security number, right? I'm not sure I want Bob in the next cubicle either, right? So I don't want anyone really to get at that information unless you as the developer decided that it's crucial to the job you're doing. So limit the surface area, send summary data. There's also some techniques that I've used occasionally, and that is to actually send down XAML to do the computation to create the graph you need, and then just send down the visual data. Depending on what you're worried about or the payload, all those techniques are okay. I just want you to be conscious of it. Don't think just because you're trying to reuse code that that's always the right thing to do. Data Services has a feature called projections, actually tracked projections, which allow you to do projections and link on the client to get that summary data without changing the model in the back end, and that's another useful way to do it. Unfortunately, RIA Services doesn't have anything built in for that, so if you're using it. So you have intellectual property that you're concerned about, algorithms, labor. To protect this stuff, we've talked about obfuscation, code runs in the client, and that the stuff has to run on the desktop. So you have to really look at what the stuff you want to protect is. What is your intellectual property you care about? And as much as I'd like to say to the designers that the look of the application is worth protecting, it's not. And the labor in writing the application isn't either, as far as I'm concerned. Whoops. Unique implementations? Absolutely. Sensitive data? Absolutely. So in both of those cases, I would protect them in a number of ways. Again, we've talked about leaving them on the server, obfuscation on the client, sending summary data, those sorts of situations. Does that make sense? So we talked about generating server. Okay, let's talk about protecting your ZAP files. Silverlight apps are just files, right? They can be served by any sort of web server. There isn't special magic code, except for RIA services, on the server. It's just a ZAP file. So they can be protected like any file. Cookie-based authentication like Forms Auth or Windows Auth, and we'll actually see in a minute how to do that. So before we get to that, let's actually look at some code. I've got a really interesting app here. I'm going to try to see if I can sell it to somebody while I'm here. It's MVC2, Silverlight 4, it's all the latest stuff. Like the circle. So here we're going to an application and I'm hosting a Silverlight app, and there's no authentication built in. So that if I look at this page and go to client bin, I can get hands on the ZAP directly, right? It's allowed me to do that. But what if I don't want that? What if I want to put the ZAP on the server and protect people from getting at it? It's just another file. So let's first show you Forms authentication. And I've added Forms authentication here. It was actually built in by the template by default. It's not doing anything special for Forms authentication. I'm just going to the client bin directory and creating a web.config and saying, hey, whoops, don't let anonymous users get me anything in this folder. Could also do it at the ZAP level as well, but I'm doing it at the folder level to be easy. Everyone comfortable with that, how that works? Nobody? So of course now we get the gray screen of death because our app is not actually loading. If we go back here to client bin, we'll see that what's actually happening if we go to client bin, Silverlight security.zap, what is actually returning is the HTML of the redirection. So we're protecting it. So let's go ahead and log on. Now I can get it. And as long as I continue to stay logged on, I can go back to the home page, and it works. Using that same cookie semantic to protect that. Now you don't have to be using forms authentication here. Forms authentication is just a built-in cookie-based authentication. If you have your own, you've written one back in 1.1 that you're still using, you have a reason to have fast expiring cookies or something like that, this is still going to work. It's just a file. There's nothing special about it. In that same vein, you may, let's go to the controller. My about box I have marked as authorized as well. And so you really need to do both those levels of protection typically. Protect the page you're going against as well as the zap. So I'm going to protect the zap from people getting at it. But to really give the user the experience that we want, which is you can't get at my application, I'm not going to allow the about box. Of course, once I'm authenticated, about will work because I've both required that the about page is secured, and I've also made sure that the zap was secured. So they both halves typically are handled that way. Does that make sense? So there's a facility in excuse me, in Silverlight 3 and above that allows you to take forms authentication and create a WCF service to allow you to log in from Silverlight, essentially. So it just creates you would create a service reference, and you'll be able to log in directly from the Silverlight client. And for full-page Silverlight apps, that's a pretty typical scenario. But that does mean something. If you have login inside your Zap, that means the entire Zap needs to be downloadable to anonymous users because they haven't logged in yet. So the trick there is to usually use composition like Prism, MEF, so that you're getting an anonymous small surface area Zap that then loads in once login happens the rest of the large app. If you don't have other reasons for doing things like Prism or composition, just for this reason, there's in the Silverlight extensions open source project, there's a handy class called Bootstrapper, which you basically pass it a bunch of zaps to load after the application has started, and it'll allow you to create a Bootstrapper really easily. But in this way, you're going to make sure that the initial zap is free and clear to anonymous, but the rest of your zaps are protected. Questions about that? So to protect your services, you really have three methods here: token-based, cookie-based, or Windows authentication. Token-based is pretty much where you're going to call into the service with a token, usually a fast expiring token, and that's all manual sort of. Cookie-based is going to be anything like Forms Auth, and we all know what Windows authentication is like. So let's talk about why this works. In Silverlight, the default stack is something called the browser HTTP stack. It's one that's been there since 2. And so I have a browser and my Silverlight app sitting in here. And this is true even out of the browser. That'll be a little different when we talk about it. My Silverlight app goes to make a network call. And what's a network call? Calling a service, requesting an asset, anything. That network call gets routed into the browser, and the browser says, okay, I'll make it for you. And because I'm making it for you, all the payload goes with it. The NTLM identity, if you have it, session ID, cookies, but magically, because the browser's making the request for us, anything that the page has as state goes to the server. Which is why using something like Forms authentication just works. So let's actually talk about that for a minute. May have my slides out of order. So what essentially happens when we run this app, Whoops. Oh, I don't have it running. Oops, I commented out the code. I have on the server, I have a dumb little service here. Oops, wrong project. I know you're here someplace. Here I just have a little piece of code. Let me mark some code. And let me make sure that our client is actually calling this. I've already set up the service references, so let me just uncomment out a couple lines of code. So using the proxy, I'm calling the service, handling the event, and then calling it asynchronously. So right now we can't get into the service, or we can't get into the Zap because we're not authenticated. But if I come in here and say security, what's the name of it again? Sorry about that. Test service.svc, and I spell service correctly. I just learned to type a couple of days ago, so I apologize. So at this point, we haven't protected our service. We stopped the Zap from loading, so you're going to have to do the same thing here. You're going to have to protect your services from this as well. Luckily, it's just a file. SVC is just a file. So if I copy my config down to my service directory, it will forward me. So now my service itself is protected. I can get to the service, and I can also get to the code. This loads, and I'm actually stopping in the service. Now in the service, what is that identity? That identity in this case is a forms authentity with Sean in it. And so I can actually go and get membership, get local, and the other stuff you may need to do to actually use stuff on the server about who's identified. This is no different than it has been in ASP.NET since 2. Just we're using it with Silverlight. Silverlight isn't going to imply any of that stuff any differently. So when calling external services, it's often thought of why not use basic auth. And there's actually basic auth support built into Silverlight 4. And if you're going against things like OAuth or basic auth like the Twitter API, go for it. But exposing basic auth to your really secure services just isn't a good idea because it's not secure. The credentials go over as plain text across the wire, and the headers typically are forbidden. You have to use this very special technique to get at it, and I'll actually show you this in a minute. So let's talk about integrated. It's the same story, except you're going to be hosted in IIS, and you're going to need to set rights to the specific folder. So I actually have an example, pretty much the same example we had before. By the way, when you're hosting something in IIS, you need to run 2010 as admin, just so you know. So I'm actually using IIS to host it, and that's not going to work. So this is a different page. It's just going to do it full screen. And here in the web.config, oh, actually, I have turned that off. Let's talk about that in just a minute. Let's set our breakpoint. Good, it's set. And up here we will switch our clients. It's basically the same service in both places, just one's pointing at the new wonderful server. So here we're being called in through Windows authentication, and identity is a Windows identity, which is me. And this is going to work the same way you expect it to. You're going to need to set the Windows authentication and then use it. And so when you're doing things like calling into backend servers, it'll be running in that same context. So there's nothing really magical here. The interesting thing is, this is a little harder to set up because you're dealing with IIS instead of dealing with just forms authentication. But for those cases when you need it, this is exactly the right thing that it's doing. Now, if I wasn't on my own box, it would have prompted me for credentials like you would expect from IE. I think I have the IE9 set up to... actually, let's do this. And don't count the number of letters in my password, please. Make sense? So using both methods just work with Silverlight, and Silverlight hasn't done anything special. Just sort of works. And all of this just works because we're going through the browser. So let's talk about why that's a problem. So, yeah, we talked about cookie-based. I want to get beyond that and token-based. One of the problems when you're doing this authentication with services is be aware that add service reference doesn't play well with authentication. So I find myself every time I need to update the reference, turning off a security, add the reference, turn it back on. I've been requesting this for about 3 versions of Visual Studio that they fix this, prompt us, do something. Even Windows authentication, it fails. So client credentials, and this is in the case where you need to send client credentials as part of the header of the SOAP header in WCF or as MX. It's not suggested because they are plain text, but if you're using SSL and you're in a fairly closed environment, it does work. They do support it. It does require SSL, even on the dev server. So be aware that when you're trying to make this work on your machine and it's blowing up, it's probably because you're not using SSL to debug it. And this is the forms authentication service I hinted at earlier. This allows you to create an SVC file pointed at this service host, and this will expose an endpoint that allows you to call, change password, log in, everything that the forms authentication service does. And primarily this is used to create a service reference to this service so that you can have a login that's completely inside of Silverlight. Unlike our example where when we aren't authenticated, we're forwarded to another page, we type it in and we'll come back to the Silverlight. In the case of apps versus websites, you'll want to log in directly in your application. Does that make sense? So let's talk about the client HTTP stack. In Silverlight, there are 2 ways to call out of your application. One's the browser base we've talked about where you get all this stuff for free. The other is the client stack. The client stack is the only stack that's available out of the browser, so you're going to have to understand it unless you're only doing in-browser applications. So the good thing about the standard browser stack is that it uses cookies and NTLM by default, just works. Looks and feels like the browser, so you're getting feedback. You'll have the little loading bar show up in the icon in the browser. You can even have the user cancel a download with the X, even though it's really in a call going through the browser. The problem is that it doesn't really support REST well, because the browser stack is ancient. About 3 years ago, I talked to the Astoria guys. I said, well, why are you doing all this weird stuff? Can't you just update the browser stack? And they said, well, no, We don't own the browser stack. They're still using, most of the browsers are still using an old browser stack that was invented by Netscape. So that it does things like only do get and post, no other HTTP verbs at all, which makes REST pretty difficult because you can't live in only get and post. So after promising me that it was too much work and they would never write their own client stack, they wrote their own client stack. What the client stack does is allows for these other verbs, put, delete, options, etc. You have more control because you're getting good status messages from the server. One thing about the browser stack, which isn't really about security, but if you haven't run into it, it's important information to know. Every error on a server is always returned as a 404, no matter what the error is, which is just painful. And you have more control over bodies and headers and that such. But it does mean you have to do a little bit more work, because if you're using cookie-based or Windows-based authentication, you have to manually put into stack every time they make a call, inject these into the cookies, inject the identity into the client stack, because it's not going to do that by default, because it's not going through the browser. It's a completely client-side stack. When you're out of browser, you're always using this. Important to know. So let's talk about how the client stack actually works if you're not out of the browser, where it just changes it. There's a class called the Web Request Creator, and it has a client HTTP property that from it you can actually create client stack calls. And that's if you're going to do it kind of manually on a one-off basis. I need to do a GET call out to the Twitter API, but I'm going to use the browser stack for all my integrated stuff because that's fine. You can mix and match these. More commonly, you're going to specify with something called register prefix. Register prefix says, I want you to take this prefix, and anytime a URI, a resolved URI, starts with this prefix, use this specific type, either browser or client-based. And that way your networking code doesn't have to change back and forth. You can actually change them on the fly here. So this is going to say that I'm going to use the client stack for anything that starts with HTTP : //. More interestingly is I could say, make sure you use the client stack for everything that starts with HTTP : //api.twitter.com. So that only calls that go to Twitter are done that way, and the other calls. It also makes it easy to switch them later on in code base. Because all of the same code, after you've done this, underneath the covers will use the right stack. So here, doing a plain old web client, handle it, download it. This is going to use whatever stack was specified based on the resolved URI. Is that confusing to anyone? Cool. In the client stack as well, there is credential support. So this is basic auth, only supported in the client stack because the browser stack specifically forbids the header. The browser stack itself, not Silverlight's implementation on top of it. So here I can pass in the network credentials, say don't use the default ones, and it'll use these basic auth credentials. Doesn't require SSL because there's a number of basic auth scenarios that aren't in SSL. And this is another way to get at the same thing. Now, there's a problem here. Usually Microsoft gets their tooth chipped because they don't follow the spec and everyone else follows the spec. This is one case where they actually followed the spec, and there's a couple of APIs out there that didn't follow the spec. So the basic auth spec is this. You make a request without credentials, and I'm going to give you an authorization required, or authentication required, I don't remember what it is, failure. In seeing that authorization is required, then make a second request with the basic auth. And what that does is that prevents you from bleeding your credentials into situations where you don't need them. That's what the spec says. But a number of places will just, if you don't have the credentials the first time, they won't give you the right return result, and the second call in won't be done because it won't expect the 3026, I think it is, 3028. My memory's not very good because I'm an old man. So that's in fact exactly how this works. Occasionally when you're using basic auth here and you find it's not working with a site, unfortunately it's the site's fault. Twitter actually was doing this and they've actually fixed their implementation. So Twitter works now with basic auth instead of in addition to OAuth. But be aware of that when you're using this, is because you can implement it without actually reading the spec. There are going to be some sites that are just going to act wacky and not do the right thing. Wow, I'm running early. Well, let's start with some questions, and we'll kind of go from there. Does anyone have any questions about anything we've talked about? Really? Okay. Can you go to the microphone so that it can be picked up on tape? Tape, isn't that a funny word? So the gramophone can play it back later.
What's my best option if I want to secure my .cf service, but not use Windows authentication, just credentials, just use the client the client stack and pass the credentials down, or?
No, typically how I suggest people handle that is with token-based.
Token.
So you'd make a call in to get a short expiring token and use that for subsequent calls. It's not a perfect system. There's not a bulletproof way to secure web services in general through Silverlight because of the shared secret problem, but you can really lower the surface area of protecting them by using tokens generated on one call and then using subsequent calls and just having them expire frequently. Okay. Sometimes seconds at a time, depending on the volatility of your data.
Thanks.
Other questions? I'm going to make you sing if no one has questions. Really, no one came with a special little problem. Oh, good.
WCF generates the services dynamically. How can I protect this? There's no file in WCF here services.
Right. So you're talking about RIA services?
Yes, here services. There is no file, no service file, because they generate dynamically. Correct.
So how to protect that, in fact, they've kind of rolled their own magic there. So let me see if I have a pre-built one I can just load in. What is that sound? Oh. Or a squeaky sawhorse, or whatever they're called. RIA. It hasn't been that long since I did this. Oh, there it is. So I don't know if you know this, but you go clockwise to speed up Visual Studio. Counterclockwise slows it down, though, so be careful. Did you not load? Don't you love RCs? Oh, I'm debugging. No wonder it won't let me. Whoops. I used to think this was a fast machine before I started to use Visual Studio in it. Don't tweet that. So this is a project that you can get out on my website. It's a kind of a thought in motion of how to write RIA services with some good architecture. So I have a service down here called models. Where's my data? Client. Oh, there it is. Oh, that's the file I'm already in. Oh, isn't that wonderful? So they're actually doing with attributes. So I can say requires authentication to protect them, and then as long as that service is called, and as long as you're using Windows or forms of authentication, it's just going to look under that is authenticated in the identity. I don't remember who asked the question, to secure them. You can also put this on a per operation basis as well. And that's typically how you protect it, is instead of protecting it at the web.config level, you're protecting it directly in the service. It's as safe as you doing it the other way, because both of them are doing the same thing. They're looking at the HTTP context .user, .current.user, identity is authenticated. That's all they're doing. So in that way, it will work across any provider model. So if you have your own authentication scheme, you're using something built in, you're using Windows, it just works. If you're using AD, or you're even using something like an LDAP store, as long as it fits into the ASP.NET model, it just works. Now, if you've got LAMP or something on the server, all bets are off. But other questions? Wow. Well, thanks for coming. Can you ask it at the... I don't want to lose. I don't have to repeat your questions, honestly, while I want you to do it.
Still here services. We could implement our authentication methods in REST services. It's better than use forms authentication and Windows authentication?
Well, forms authentication and Windows authentication are for very different needs. So Windows authentication isn't a good solution if you have everyday non-domain users. So if you're going out like over the internet to customers or partners, it doesn't make a lot of sense to use Windows authentication. It just doesn't scale up. So forms authentication is fine. You could write your own, but if it's for tighter security, I'm not sure you're buying yourself much. There's a lot of knobs to make it more secure, to make the passwords more protective, to expire them fast, and all the things you would want if you wrote your own. So there's back in .NET 1.0 and 1.1, you really had to, but now there's not a whole lot of reason to do it. I'm sure someone in this room probably has a specific reason for doing it, but there's not a common one. Question?
So is there stuff similar to cross-site scripting that you have to worry about with Silverlight?
So cross-site scripting, it isn't and it isn't, because the way that calling down code or assets or making calls to other services works is it requires permission in the same way that Flash does. So that when I call out to eBay.com to use their API, if eBay doesn't allow me there by using a secure, what is it called again? The security access configuration. It's a magic XML file that is on their server to say, please let these people or anybody into our API. But until that's there at the root of their domain, Silverlight won't let you make the call. And that's really to do the same thing that the browser's doing with JavaScript. JavaScript isn't allowing you to go get other JavaScripts off of other sites because of cross-scripting concerns. You can get around the requirement in Silverlight by just calling it from your server. So you think, well, why is it that protective? It's protective because when you're doing something nefarious to their service, it's coming from a server you own typically, or they can be traced back to you. When it's coming from the Silverlight client, it's whatever naive user is running your Silverlight application that's doing that nasty thing you asked them to do. So it's much less traceable. Silverlight, for those that don't know, actually they support two of these XML formats. One is the Flash standard, and one is a Microsoft-specific one that has some more granularity. That means that anyone that already supports Flash, Silverlight is grandfathered into. So that's why eBay and Live and all these other sites you may want to go against their APIs just work, because they've been allowing Flash for years.
If I use the tokens approach, I'm assuming I'm not going to use the HTTP context condition.
Correct.
What am I going to use in that case inside the service?
Well, you could either use by sending it as an additional SOAP header and then checking it on your side,
okay,
or even a parameter into the call. But it's going to be custom. There's no token-based
gotcha.
WCF wrapper that just works. It's pretty easy to implement, but it's just something you're going to have to do.
And in that case, it makes sense to use HTTPS, I guess, SSL.
Well, In those cases, if you're protecting them, it probably makes sense for a variety of reasons.
Or I can encrypt
But
encrypt
that
the
would include it.
parameters or something.
Well, the big protection is you're going to encrypt it, you're going to salt it so that someone can't make their own and just guess right, and you're going to make them expire fast. So if someone does steal across the wire, they're going to have a small window to hurt you.
Okay, makes sense. Thanks.
What about like client certificates and certificate pairs? Is there any way?
I haven't done it with client certificates. My understanding is it just works as long as it's there. It's coming through the same, as long as you're using the browser stack. I don't know that there's a way to get the client certs and inject them into the client HTTP stack. But I could be wrong. I haven't done it, so I don't want to promise you it works. Yeah. But through the browser stack, it's supposed to just work. At least that's what I've been told. Any other questions? We have about 9 minutes.
Hi, if your application was hosted in the Azure cloud, is there anything here that you've told us that you would do differently?
No. If it's in the Azure cloud, it's pretty much the same scenario if you're using Windows Azure to host it. Yeah, it's no different. The one trick that I'll mention since you talk about hosting is if you're not in a big environment where you have a lot of control, let's say you're using shared hosting, you're in a startup, or you're just doing Bob's blog and want to do something there. Some hosts don't support ZAP as a format that they can protect and serve. And so Silverlight doesn't care as long as the ZAP isn't cross-domain that it's called ZAP. So if it's from your own website, you can call it .zip and it'll work just fine. I would only suggest doing that in the case where you don't have control over actually adding those MIME types.
If you secure the ZAP with forms off, like you showed, running out a browser, like the second time, what's going to be involved there with pulling down updates?
Pulling down updates end up being the same process. So as long as the cookies, so for out of browser, let's assume you called the service to authenticate yourself with forms off. You would just need to go to the cookie collection in the that you got from the service, and you inject it. There's a cookie collection in the HTTP client, and you can just fill it. It's a 2-line thing, but you have to do it in every case. Usually, you end up writing a factory for your connections, and then for the update, you supply it not the connection, the client, the web client that you're going to use for getting those. No, you'll actually, the first time you call the authentication service, the question was, will you have to call back to get the cookies? You won't. What you'll do is on that first request is you'll cache those cookies in your client and just use them. No, in subsequent restarts, you're going to run into timeout. So probably you'll have them, if they do a restart from the desktop, you'll have to actually have them authenticate again. I mean, you could make the timeout be weeks at a time. It's just not a good idea. People can steal cookies. And the others, or is everyone ready for more coffee? Well, thanks for staying. I'll be outside for a few minutes if anyone has questions and are too shy to get up to the microphone. And thank you.